Hi, in this video, I'll go over why and how you should always visualize the graph of the absolute value function, either visualize it in your head or actually sketch it on paper, whenever you solve an absolute value inequality. You may have noticed by now that solving absolute value inequalities is more complicated than solving linear inequalities. For a regular linear inequality, you can just use the same methods as when you solve an equation. You just pay attention to the direction of inequality, and whatever you get at the end is the solution. Absolute value inequalities are not like that, even though the inside of the absolute value may just be linear. They involve different solutions depending on the inequality. For example, all of these inequalities are solved differently. The first one, absolute value of 3x plus 1 less than 4. The solution consists of one interval. This next one, the answer is a union of two intervals. And then this next one, absolute value of 3x plus 1 is less than negative 1. There's no solution. I mean, if I change it a little bit, absolute value of 3x plus 1 is less than or equal to 0. Then the solution is just one number, not an interval. Why is it like that? The answer is because of its graph. Here's the graph of absolute value of 3x plus 1. It looks like a V. Let's say we need to solve absolute value of 3x plus 1 is less than 4. Then on the graph of y equals absolute value of 3x plus 1, the inequality means that y is less than 4. That means vertically, we're looking at the part below the line y equals 4. That's this part of the graph. And we need to give an answer in terms of x. So we look for the x values that belong to the part of the graph below 4. It helps if we only look at that part of the graph, so let's separate it out. The question is, if you look at this letter V here, what x values go with this portion of the graph? Well, the answer is this interval. And that happens to be from -5/3 to +1, but I'm not emphasizing the actual numerical values in this video. What I'm pointing out is the answer is this one interval on the x-axis that goes with this one piece of the graph. That's why the solution to the inequality is just one interval. All right, now let's try another inequality. Absolute value of 3x plus 1 is greater than 4. Again, we draw the graph and we draw the line at 4. And if y is greater than 4, then we want the part above the line y equals 4. We need to give an answer in terms of x, so we look for the x values that go with this part, and it's these x values right here. And look, they don't come in one piece, they come in two pieces, one to the left of -5/3, the other to the right of 1. And so that's why the solution is a union of two intervals. The graph, when you cut by the line y equals 4, and you take the part above it, consists of two branches. So the x values that correspond to these two branches come in two intervals, come in two pieces. So that's why the solution is the union of two intervals. All right, moving on. What happens if we have this inequality? Absolute value of 3x plus 1 is less than -1. Well, the graph looks like this, with the -1 way below the V. And so if you're looking for the absolute value being less than -1, well, no part of the graph is below -1. And therefore, there's no solution. And that makes a lot of sense because an absolute value is always positive or at least 0. It's always greater than or equal to 0, so it will never be less than -1. All right, well, let's switch the direction and try absolute value of 3x plus 1 is greater than -1. Well, here's the graph, and the part that's greater than -1. That's the whole thing. The entire graph and all of its x values are above -1. Therefore, the answer is all x values on the x-axis, and we write it as all real numbers. And that also makes sense. An absolute value is positive or at least zero, so it will always be greater than -1. Alright, so for new practice, you may consider these two examples and try to draw the V shape and sort of figure out what kind of solution it has before actually doing like numerical work. Right, example 5, absolute value of 3x plus 1 is less than or equal to 0. And example 6, absolute value of 3x plus 1 is greater than 0. All right, so in summary, number 1, the graph of absolute value looks like a V. And number 2, don't try to memorize all the rules of solving absolute values inequality. Things like, oh, if it's greater than, then there are 2 branches, then if it's less than, then, I mean, you can make a list of all the different possibilities, but it's too confusing, extremely hard to memorize, and even if you have your notes for an open note exam, it's confusing, and you're likely you run the risk. You run the risk of reading the wrong rule and applying the rule incorrectly. Instead, what you should do is number 3, try to visualize that graph that looks like a V. If necessary, sketch it on paper. You don't have to draw a very nice graph, just a quick sketch. And then from that, you deduce what type of solution you should be getting. I hope this helps. Thanks for watching. Bye.